Hello, I'm Dr. Harper. This video is in project management, and this is a homework video, homework number 4. I'll be talking about the Golden-2 project within homework number 4. So now this video, although I'm talking about just the Golden-2 project in homework 4, which is PERT with parallel paths in the critical path, this is really more a combination of a lecture and also working the homework problem. So this is talking about parallel paths and also some takeaways on the lecture, as well as the homework problem, and show you how to work the problem. So as far as I'm concerned, I think the homework problem is minor, but understanding the concept around that homework problem is even more important in this video. So first, let's bring up an agenda. So in this agenda here, I have, let's get in the center here, for parallel paths in PERT. I'll be talking about homework number 4, questions 19 and 20, the Golden2 Project. And that's really a modification of homework 3, question 19, the Golden1 Project. And so it's an extension or modification. It's a modification and an extension. Okay, now the resources here, first of all, will be from my website, mdharper.com, and we'll go there and I'll show you where it's at. The tab, Project Management tab, the heading is CPM and PERT Introduction, and under that we'll have 2 Word files. Actually, 1 Word file, the CPM PERT, but in that 1 Word file, the CPM pages 7 and 8 talking about parallel paths, and then PERT pages 14 and 17, how the parallel paths are handled within PERT. And then also in the website, just below that, is the Excel file, the PERT Excel. And this PERT Excel, once I've gone through explaining it, then this Excel spreadsheet can be used for the homework. Okay, and just download it and then use that and get the homework answer. But the main thing is so getting the homework answer is kind of like validation. Yes, I did go through it. Most of the learning is not getting the answer, is understanding why you're doing what you're doing. Good. So let's back up here. Let's start with the homework 4, questions 19 and 20, Golden2 Project, and compare that with homework 3. So let's bring up homework 4. Here's homework 4 questions, and you see, first of all, this is homework 4. I'm coming down to question 19 and 20, and here it is, Golden2 Project. You have been selected to analyze the Golden2 Project, which is the same as the Golden1 Project, except for the time estimates of activity G. The team requested the time of completion along with a schedule consisting of a Gantt chart. Also, the team was concerned about the likelihood of completing the project in a reasonable length of time. 270-day target was suggested. So notice what I'm saying here. 1 is a Gantt chart, and that's used for scheduling to see what the project is like big picture. A Gantt chart would be a big picture. There are different type of big picture perspectives and visualization of the project. The second thing is a 270-day target with the probability of being greater than that. So that's being more detailed oriented and more specific within a project. So usually when you analyze analytics, you're looking at the bigger picture and you're looking at the details. And you can't do one without the other. The details are important to understand the big picture. The understand the big picture is important for the details. So let's go on. So notice you're in the planning process of the Golden2 Project. The time parameters were collected in the table below and distributed to the team, consisting of predecessor activities along with the 3 time estimates. Now notice down in here, I repeat the Golden1 Project because they pulled up the Golden1 Project, but then I highlighted G and those were changed in the Golden1 Project. So I was trying to emphasize that this G here becomes the Golden2 Project, but you start with the Golden1. Okay, in other words, just to emphasize that one little point, let's bring up, whoops, did not mean to do that. Let's come back. Here's the Golden1 Project. Let's bring back, let's go to homework number 3. Here it is. Homework 3. Here's homework 3 answers. Let's come down here to the bottom. come to the bottom down here. So here's the answers down here. Number 19. So here's the Golden-1 Project, and that was homework 3. If I come down to here, I just want to emphasize and demonstrate that these are the same. They are the same numbers. If we can get them on the same page here. 20, 27, 58, 20, 27, 65, 50, 68. So they're the same project, same predecessors, except for G up here. That's the only thing let's come up one more here. That's the only thing that's really different, and that's why I say Golden-1 Project, to emphasize that it is a Golden-1 Project. Now, the reason I'm emphasizing that is that we can go back to the Golden-1 Project and look at the solution down here. And there it is in the answers that I gave you. And so here's the Golden-1 Project with these times. The time of completion was 2:58. And here's is the CPM. Now remember, in the Golden-1 Project, you have the optimistic, most likely pessimistic. You get the mean and the variance. You take the mean as the time, and this part here is the CPM. Early start, early finish, successor, late start, late finish, slack. That's the CPM. And notice the critical path is activity, let's see here. Activity B has a slack of 0, activity E has a slack of 0, and activity H. And so it's BEH. So you come up here, and then I. It's BEHI. That's the critical path. Now, to get the probabilities, you take the mean and the variance of the critical paths. You sum them up. So with this mean and variance down here, I bring the mean down here. I'll have the mean and variance of BEHI. But I also take the mean and variance of the other 3 paths. And notice we have ACF, ADF, ADGI. Okay, so ACF is the top path, then ADF, then ADGI, and then BE. So this is the critical path. Why? Because if you look at the mean here of ACF, it takes 203 is the time, 228 is the time, 183 is the time, 258. Well, the critical path is the longest path through the network. That's why BEH is critical. But we also add the variance of those paths, of those activities in those paths, and the standard deviation. So the point here is that when I start looking at different times and the probability of less than or equal to those times, I go 258, 260, 270, 280, 290, 300. I calculate the probability for this path, ADF path, ADGI path, and BEHI. These are the probabilities using Excel. Why? Because I want to demonstrate that this path here, when you come up to here, notice this is 0.5, 0.5, 0.7. And so if you're looking just at this, then the 0.7 then is the answer, and 1 minus that is 0.32348 or 235. And that was the question on this homework assignment. 0.23 or 24, I think it was something like that. 24, 235, 24, whatever, or 23, anywhere in the 2-3s areas. 2-3 is all I would accept. I think some people said 2-4, 2-5. It depends on how you do the calculations. Okay, then I plotted the Gantt chart down here. And for the Gantt chart, all you need is the early start and the duration. And you take these and you plot them. And I think I've demonstrated that. If not, I'll demonstrate it again. You just ask and I'll show you how to generate a Gantt chart very quickly within Excel. Okay, so that's how we did PERT for the Golden-1 Project. No problem. Okay, now let's go back to the agenda. So now that's homework 4 and homework 3. But now let's look at parallel paths. Now we go to the website here, mdharper.com, my website, and there it is. I come down the Project Management tab, And there it is. I come down to, here's a lecture material, here's PMBOK 1, here's PMBOK 2, Word file for PMBOK 2. Here we go. Material for the CPM and PERT introduction. Okay, now we're first going to look at this Word file right here, and then I'm going to come down and look at this Excel file. So there's a Word file and an Excel file that I'll pull down. First, let's look at the Word file. Okay, let's download this and pull it up. Let me pull it up. Here it is. Now, in this Word file, I have the notes for the CPM, these 5 different topics, and then for PERT, these 5 different topics. So what I want to do first is talk about CPM parallel paths right here, and then go to PERT, talk about parallel paths, PERT actually, critical path, and then the parallel paths. Okay, and there's where I talk about CPM pages 7 and 8, so let's do that first. Let's come down to 7 and 8. Let's see here. This is too far. Here's 7 and 8. Okay, for CPM, we have this definition, 7 activities, predecessor duration, and I go through the CPM and get the slack. So when I do that, I can see the critical path is activity 1, activity 3, and activity 6. 1, 3, and 6 on the AOA. AON is 1, 3, and 6. There they go. Okay, and so therefore, if you look at all the paths, 1, 3, 6, the duration of 1, 3, 6 is the greatest. That becomes a critical path. The one with the greatest path through the network. And so then I highlight in the Gantt chart. Okay, so there's the CPM. But then we come down here to CPM with critical paths. Okay, to do that, I change the duration of activity 2 to a 4. Now notice up here, activity 2 has a duration of 2. So the duration here is 2. But down here, I change that 2 to a 4. But when I do this critical path method, the CPM, notice what happens. Here's the early start, early finish, late start, late finish, and notice the slack here. Activities 1, 2, 3, and 4 are critical, and activity 6 is critical. So the only 2 activities that are not critical are activity 5 and activity 7. So let's come back up here. Activity 5 and activity 7 are the only 2 that are not critical. So I have a 1, 3, 6, activities 1, 3, 6 are critical, and 2, 4, 6 are critical. So I have parallel paths in my critical path. So how do you know that? How do you know you have that when you solve this thing? Well, remember, when you solve CPM, the maximum of the early finish here is a time of completion of the project. And that's true. And that's true whether you have parallel paths or not. But if you come up here, if you take the sum of all the critical activities, 1, 3, and 6, that time of completion of the longest path in the network and all the activities in that path will be the time of completion. Okay? So let's do that down here when we have parallel paths. Well, when you have parallel paths, if you take the time of completion of each critical activity and sum it, you have 17, which is greater than the time of completion. Okay? So I'm doing this differently here than I did above because I'm taking the time of completion. Well, that time of completion is the sum of all the critical activities, unless the sum of those critical activities is greater than the time of completion. And if it is, that's the indication that you have parallel paths in your critical path. When the sum of the durations of the critical activities is greater than the time of completion, then there are parallel paths in the critical path. So here's an example. So notice up here, oh, I think I did it down here. No, I did crashing. Here we go. Activities 1, 3, and 6, and 2, 4, and 6 are critical. Well, if I add 1, 3, and 6, that's the time of completion of the project. If I add 2, 4, and 6, well, 1, 3, and 6 is 5 plus 2 plus 3 is 10. If I add 4 plus 3 is 10. Well, both of these have a duration of 10. But notice 5 and 2 are 7, 4 and 3 are 7, 7 are in parallel. I'll be adding those twice if I add all my critical activities. And that's why this is 17. And when my time of completion is 10, this is 7 more because there's a duration of 7 that are in parallel. Okay, which is a clue on how to analyze parallel paths. We won't get that far into it. If this was a network analysis, theoretical network graph theory, then we probably would, but not here. This is just takeaways for business in analytics. Well, how do you deal with that? How do you find the probabilities? Now let's go to PERT and talk about probabilities. Okay, and coming to PERT, this is page 14 and page 17. So let's bring this back. Come down to 14 and 17. First 14. Here it is, 14. Here's PERT. I go back to the original problem where I have 2 here. But then for PERT, I change the duration here from just one single value to 3 values. An optimistic, most likely, and pessimistic. And from those 3 values, I take the mean, or the expected duration, which is the average, the mean. The variance of the duration with those equations. I take the expected duration. Expected is the same as the mean or the average. This expected duration, I put it into CPM, and I calculate the slack. I'm not showing that here. I would take those and put it in the CPM algorithm and get the slack. And so here we go, we have it. And now we can see that activity 1 has a slack of 0, that's critical. Activity 3 is critical. Activity 6 is critical. I take the critical paths, I take the expected duration and the variance of the duration. The mean variance, I add them up, and there's the mean and variance of the actual project, 11.2, with a variance of 2.25 days. If this is days, I don't remember what it was. It's time. But now that we have the mean and duration, as we did last time, as we've done before, now we can take the time of completion. It follows a normal distribution because technically the way this is developed, the modeling of this, these become beta distributions. And when you sum beta distributions by the central limit theorem, they approach a normal. So using the normal distribution is a very good approximation, and the probabilities are very, very accurate. Okay. Where the mean is 11.2 and the variance is 2.25, which implies a standard deviation, well, the square root of 2.25 is 1.5. Okay, then for these fixed values of t, I calculate a z. I put it into the this normal standard normal distribution Excel function, and I get my probabilities, and there they are. And there's the actual probabilities of how to do it. So this is what we did for homework number 3. Now for homework 4, then what happens is, let's come back down here to 17. This is the homework 4 basis. So here I take the same problem, but I change activity 5 to 3 different estimates of the time. And so I have a new expected duration and a new variance. So I've changed this one row. But when I do that, and I take the expected duration and put it into critical path method, I get this set of slacks. And now I have 1, 2, 3 are critical, and 5, 6, 7 are critical. The only one not critical is activity 4. That's the only one not critical. Okay. Well, when I look at the only one that's not critical, let's come back up here, it's 4. So I have 136, 137, and 257, okay? But notice 136 and 257 are parallel. So those are the two parallel paths. Now 7 is common with 1, 3, and 6 and 1, 3, 7, but then 7 is critical because its part is 2, 5, and 7. Okay? So therefore, I take 1, 3, 6, and 2, 5, 7. I pull the mean and variance off of activity 1, activity 3, then activity 7, or activity 6, I'm sorry. And then I add these up, I get 11.2, and there you go, 11.2. I take 2, 5, and 7. This is 2, this is 5, this is 7 down here. I add these up, I get 11.2 again, but a different variance. Okay, so now here are parallel paths. Both of these have a duration of 11.2, which is a maximum, so that's going to be the time of completion. Now, if I added all of the durations of the critical activities, what would I get? Well, these are parallel, so I'd add these up, I get 22.4. And these three, all 6 of those are going to be 22.4. Okay, so when the sum of the critical activity is going to be greater than the time of completion, boom, you have, that's when you have a parallel paths in your critical path. So how do you calculate probabilities then? Well, you do each path differently. Take each path at a time, and that's why I did it before. I showed each path. Okay, first of all, let's just take the critical paths though. 136. So here's 136 for times of 9, 10, 11. 11.2 is the mean, 12, 13, 14. And I take this there we go. For 1, 3, and 6, I take this mean and variance. I calculate my z's for each one of these t's and the probabilities, and there they are. But I do the same thing for the other path, 2, 5, and 7 here. So for 2, 5, and 7, those are the z's. I have the same mean, but a different variance. So they're going to be a little bit different. Instead of a minus 1.467, it's minus 1.274. It's a little bit different because the variances are different. So the variances have a little bit of differences in them. I calculate the probabilities, and those are probabilities. Okay, so now I know the probability related to the path 136. I know the probability related to the path 2, 5, and 7. Both are critical, but they're parallel. How do I get the probability of the project? Well, an attractive way, in a way that people are tempted to do, very tempted, is just take the average. And that's wrong. Since the probability of the parallel path, the time of completion, when you have parallel paths, is the maximum of those two times. It's not the average, it's the maximum. So the probability of a maximum of a series of random variables turns out to something be order statistics, and the probability in order statistics, the maximum order, would be the multiplication of the probabilities. It's the multiplication of the cumulative probabilities. So I take these probabilities, I multiply them by the probabilities of the parallel path. I multiply those two together. That becomes the probability of the project. For example, let's look at activity 11. Well, the time of completion is 11.2. What's the probability that this project would be less than 11 days if the time is late? Less than a time of 11. I don't know if it's, I don't remember if it's days or weeks. Less than a time of 11. Well, one path is you have a 44.7% chance of being less than 11. The other 45.4%. Well, there's two different paths. There are 44.7 and 45.4. So logically, what would you think? It's around 40%. But mathematically, logically, mathematical logic is no, the probability is 20%. It's the multiplication, it's the product of those two, which is 20.3%. So you can see how that can be very misleading and lead to very incorrect perceptions, planning, and people will go over because they're expecting this to be a much higher probability of being earlier, and it doesn't happen. So if you have a lower probability of being early, you'll have a higher probability of being late, right? Okay, and bingo, projects have uncertainty. They all have uncertainty. And so the probability of being early or late is important when you have parallel paths. And the larger the project, the higher, the very high the probability, you will have parallel paths in your critical path. And so this kind of analysis becomes very important. Now, the analysis really requires network theory and probability theory, modeling, but as a business person, just recognize that it happens and ask the right questions. Now, to analyze this, that's what homework 4 is for. So let's go to homework 4 now. And let's use this concept. Okay, let's bring in homework 4. Let's go back to homework 4. And here it is. Okay, so what I'm going to be doing is taking the Golden1 project and just changing these numbers. Okay. Now, to show you how this works, okay, let's go back to, the Excel. Now let's do the Excel file in my website. Okay. And let's see here. Let me do it. Here we go. Oops, wrong one. There we go. The Excel file is this Excel file right here. So let's download this Excel file. Boop, I'm going to do it. And let me bring it up. And there it is. Okay. Now this Excel file, the very first spreadsheet is just the PERT. It's just solving the PERT. Okay. And so basically, I'm doing just like we did on the last homework assignment. But let's increase this. Let me show you what's going on here. Again, here are my 3 estimates. I have 7 activities here. Here's the mean and the variance. I use the mean here, down here, same numbers, okay. And this right here is my critical path, CPM algorithm. And here's my slack down here. Activities 1, 3, and 6 are critical here, okay. And so what I do here, I sum these up. Oh, let's see, what do I do? Here we go. Path 1, 3, and 6. I'm not sure how to remember what I'm doing here. Oh, I know what I did. Okay. So I take 1, 3, and 6 because I see path 1 is critical. Path activity 3 is critical. Activity 6 is critical. So down I take 1, 3, and 6. If I sum that up as 1.2 and 2.25, okay. If I sum these up, and then I take the probabilities here, and then when I calculate those probabilities over here, I plot it, and there it is. So that's the probability curve of the cumulative probability of being early. And there it is. Okay. Now, let's go to the second spreadsheet. This is what we did in the last homework, homework 3. Now, the second spreadsheet, let me open that up. And there it is. And let's enlarge this. And let's come down here and say, okay, now what we have, I'm changing activity 5. And that was in the notes I just showed you. Changing activity 5, getting the mean and the variance here, taking the duration and putting it here, getting the, let's make this larger so you can see it. This right here is getting the critical path method, and there it is. And notice now the slack down here is going to be activities 1, 2, 3, 5, 6, 7. Activity 4 is the only one that's not critical. Aha. So 1, 2, 3, 5, 6, 7. Okay. And so if I come over here and look at this, 4 is the only one that's not critical. So I have 1, 3, 6, 1, 3, 7, 2, 5, 7. Okay, like I said, 1, 3, 6 is parallel to 2, 5, and 7. Even though 7 is common to 1 and 3, okay, then 1 and 3 are common to 6 and 7, but 2, 5, 7 then will be parallel to 1, 3, and 6. So I come back here. I say, okay, well, let's come down here. And notice the, here we go. I take all the paths, 1, 3, 7, 1, 3, 6, 2, 4, 6, 2, 4, 7, 2, 5, 7. I take all, there's 5 paths through the network. Let's come back here. 5 paths. 1, 3, 7 is 1. 1, 3, 6 is 2. 2, 4, 6 is 3. 2, 4, 7 is 4. And 2, 5, 7 is 5. There's 5 paths through the network. So if I take all 5 paths, which I'm doing here, I add up the mean of the activities and the variance of the activities. Notice there's 2 of them that the maximum is 11.2. So there's 2 of them that are critical. 11.2, 11.2, 136, and 257. And notice 136, 257, there's no commonality of the activities. Now 1, 3 is common here, and 7 is common down here, but 1, 3, 6 then becomes critical, and 2, 5, 7 path becomes critical. So 7, the activity 7 is critical, but the path 1, 3, 7 is not. Okay, so here's a good example of all the activities are critical, but the path that those activities make up is not critical, because those activities are in other paths that are critical. So hopefully you can appreciate the analysis that's required for people who know what to look for, how to look for them. And so if you have only one critical, if you only have one path through the network, then all the activities on that path are critical. If you have more than one path through a network that's critical, then all the activities on a path made up of critical activities is not necessarily critical if you have parallel paths. So you see how tricky it can be, very tricky. So what I did here, I took the probabilities for 9, 10, 11, 12, 13, 14, 15, and I calculated the probabilities of all of them. Okay, and notice the 11.2 here of 136, 11.2 of 257. When you look at those probabilities here, they are low here. To be early, it's a low probability. And then it begins to increase. Okay, again, you multiply all of these together to get the probability of the project. Now, when I say that, let me caveat is that this is not the actual mathematically, this is not the true mathematical way to do it. You need to look at all the parallel paths and it becomes very complex. But when you have a large project, just multiplying these parallel paths, then although this number is not exactly the right probability, in practice this is a heuristic way of doing it, and it's a very it's a fairly accurate way of doing it, even though it's not perfectly accurate. So this is not the actual mathematical way to do it. It's a heuristic way to do it, and it will give you better results. For example, the actual true probabilities, I didn't calculate them, would be instead of 0.002635, it may be 0.0018 something or something like that, or 0.0027. It could be very close. Okay, but as you go further up, then the differences become less and less and less. Okay. Going up here. Okay, now notice 136257 both have, and the differences between 11.2 and the others, 8.8, 8.6, and 6.2, 8.8 is the closest. 8.8, 11.2 is pretty far. So when the differences between the paths that are critical to the next lowest, to 8.8, when that gets further and further, then it's easier just to take just those two. Okay, so here I'm taking just those two and doing the probabilities. So when you do that, let's see what the differences are right here in the middle. Let me take this one minus this one. Say, okay, the difference is the probability, difference in probability. Look at this. It's, and let's make this just a number. 0, 1%, 1%, 0, 0, 0, 0. It's very, very small. Very small. So the greater the 11.2 is from the next lowest, which is 8.8, the greater that distance, the smaller the difference in the probabilities. It just makes it easier. Okay? So when you see this pattern in a project of 11.2 goes pretty far down, you can do all of these, okay, but then you can say, wait a minute, I just need these two. And that's going to give me probabilities that are reasonable, very reasonable when you're looking at probabilities. I can put this up another significant figure, and this is a half of a percent, okay, and it's very, very small, small compared to the 258 or 11.2 days. Well, 1% is 1 day, half a percent is a half a day, okay, if these are days. So that's the idea, if we're looking at just days. But these are probabilities. Okay, now over here we're plotting it. So here is the probabilities of all paths. Well, the blue and the red is the probabilities, the cumulative probabilities of the two critical paths, and this one right here is the project. So if I just did the two greatest paths, and notice this green here is a critical with just these two, well, the green and the gold up here, even though this is more accurate, the differences are extremely small. So that's the way to do it. So there's takeaways. Now, let's go to the homework. What do we do in the homework? Here's the homework again. Let's bring this back. I say, okay, I have 1, 2, 3, 4, 5, 6, 7, 8, 9. I have 9 activities. And so all you do is you take the Golden1 project and put those 3 numbers in. Well, if you have this spreadsheet here, put those 3 numbers in, and all of this will just fall out. So you take the spreadsheet you had before, and then you just use it as a template. You change the 3 numbers on activity G here, like I did here on this activity 5, and then find the 270 down here and you solve it. So if you still have, so you'll still be using the homework 3 here. This is, again, let's go back. This is homework 3 answers down at the bottom. You're still going to be using this if you have this, and then on G here, you change those 3 numbers, the 30, 55, and 116, you change it to 87, 117, and 197, and then down here, you calculate all the probabilities. And that's why I did it this way, all 4 here. You do all 4 of them. To get all 4 of them, as it turns out, the probability of 270 here then will be for all 4 of these together. Okay? You do all 4 of them and multiply them together. And then it's going to make a difference. So notice here, these are so far apart that 76.54 and 76.52, it's not that big of a difference. But for Golden2, it will be a big difference. And that's why we have homework number 4 to illustrate that. And the takeaway from that, what if you don't do that? Let's bring this back. If you don't look at, if you don't look at the heuristic of parallel paths, then you can come up with a probability that's going to be 40% when it's really 30% when it's really 5%. And so you're going to have, oh, it's only 50, we only have a 20% chance of being late, or 60% chance of being late. No, you have a 90% chance of being late. Again, people can make mistakes on parallel paths quite easily, and it's very common. And that's the whole purpose of this Golden2 project. So this is more of a lecture than it is looking at the problems. You'll give pop it in there. It'll give you the time of completion. It'll give you the probability down here, and those two numbers can be pulled right off. Okay, and pulled right off of the Excel spreadsheet template. Okay, but then if you go to this topic 4 here, homework 4, I want to strongly encourage everyone in this course to use the Q&A. Open the Q&A, and I think people, yeah, hey, Megha Gupta are using it. Thank you very much. When will the homework be available? It's available. Go in there and share information, share answers, and most of the answers are just validating, did you go and look at this thing? And so share information and share things going on here, okay? And so the Q&A is going to be helpful for the topic 4 here. And so there's homework 4. It's out there. And I've even opened the homework 4 submissions, so now you can submit homework number 4 once you get these last 2. I didn't open it till today because I wanted everyone to listen to this video. So this video will be posted here when I'm done. You can look at the video, work the problem, share all that information here, and then post your answers. And next week I'll post your submissions. Next week I'll post the answers. Okay, so that's all I have for homework number 4, the Golden2 project. And as I say, it's a homework. There's a couple of answers, a couple of points, but the points is just to validate that you did look at this problem and understand the concepts behind parallel paths in the critical path in PERT. It's a big area of people making mistakes in running projects. So just be aware of that happening and ask the right questions when you're looking at complex projects over more than a couple of years, or more than just 10 or 20 different activities. Ask the right questions. Bring the right people on board to analyze this thing correctly. That's all I have. Between now and the next time I see you, I want to encourage everyone to be safe and take